Going.
We're live now.
Ishmita, so we're going to wait for some time.
Yes, we can wait for another 5 minutes. Let's people join. Yes.
Okay, great. Yeah.
Was Dr. Meenakshi Sundaram or Dr. Lakshmi joining? Either of them? Smita?
Not yet, sir. He is not there.
Or okay. Biplab, had we asked him to join?
Yeah. So we have forwarded, requested them mail also and then link. I think for the subsections usually.
I know, but sometimes they join here.
Yeah. So that's how.
Sir, you can start.
Sorry.
Okay.
You can start, sir.
Okay, great. Okay. Fine. So, hello, good morning, everyone. So, today on this session of a webinar session under telehealth subsections of Indian Academy of Neurology. So, we'll be having close interactions on one of the most talked about, impact of AI in comprehensive stroke care. That is over the last, 4-5 years. So, there's been lots of discussions, lots of moving forward, and things has happened. So there are multiple platforms which is there where we do comprehensive stroke care. We use a platform for patients' care of a stroke. Acute stroke care. So today we'll be having discussions, and there is one platform which is Nicolette. So Kylie is there from Australia. She will be talking about Nicolette, followed by an interactive panel discussions. So to take it forward. So I hand over to Professor Gurana. So I think Professor Puran doesn't need any introduction. So he has been so actively over the decades, actively engaged in comprehensive stroke care across Indian subcontinent, not only Indian subcontinent, across the world. He has been involved in so many research work, and he's been my mentor also. And he's in charge of stroke program in PGIMER in Chandigarh, and also he's interested in neuroimmunology also. So he's been the past president of Indian Stroke Association, and I think I'm not going to say more. There are lots of
Past
things.
chair of the teleneurology. You're the current chair. That's a support slide.
So to take it forward, sir.
Thank you, Biplab, for the introduction, and good morning, everyone. We have a fine Sunday morning, and I think no better day to really talk of something which is so much linked to greater access. And AI has clearly infiltrated all aspects of our lives. We are no longer thinking that AI is going to come and make changes. It is, I think we have come to terms with the fact that this is here to stay. But the way AI is utilized or has made changes in the stroke care has already been witnessed, and we've had experience with other platforms, as Biplab said, where AI made the possibility of all the thrombectomy trials which came in, and so on and so forth, so many other things. So today we have another aspect which we will be discussing. But before that, let me introduce our panelists today. And the panelists here today with me are Dr. Monica Saini. Can I have the slides, Asmita, for our panelists today? And of course, Pushkraj, who's our convener for the telehealth subsection. I welcome him also. Pushkraj is here with us. We have Dr. Monica. She is currently working as a senior physician at the senior resident physician in the National Neuroscience Institute. And she's a previous fellowship. She's a fellow of stroke from the University of Alberta, and also a fellow in dementia from NUS Singapore. She has a vast number of publications and various areas of publications. Importantly, she's won the NHG Outstanding Education Partner Young Educator Award. Well, she's been she was previously with us at PGI, and now she's in NUS. Very deeply interested in education, as well as all things which improve access to treatments, and that's why she would be a very good contributor today. And we have with us Dr. Ayush, Dr. Chirag, my friend and colleague from PGI. He works in the neuroradiology department as an additional professor at PGI in the division of neuroimaging and intervention neuroradiology. And he's a partner in crime with all the interventions that we do. He has and we have Ayush Agarwal with us, who's a colleague from AIIMS Delhi. He's an assistant professor there, huge number of publications with stroke and neuroimmunology as his area of specialization. And he has a vast number of achievements and awards. I think now we can move on to the main part of the webinar today. And let me introduce the speaker for today, Ms. Kylie Turner. Can I have her slide? Ms. Kylie is a country manager for Australia and New Zealand for Nicolab, and she's an experienced enterprise sales executive with decades of multinational experience, honed at GE and Siemens Healthineers, and serves as sales manager for Nicolab's Asia Pacific business, as well as a country manager for Australia and New Zealand. And just to also put things in perspective, Nicolab's work and the platform, it also recently won an award at the ESOC. I was there to witness that, and I've had a kind of a short peek at their software, at their system. It seems to be pretty comprehensive, and I think it will be a good fit to the system in India, where we still have difficulties or challenges in connecting to hub and spokes. So with this, without wasting further time, I invite Kylie for her talk.
Thank you so much, and good morning, everyone. Thank you all so much for inviting me to present. And Yeah, I certainly don't have as many credentials as your amazing colleagues that make up the panel today, but I'm very excited to be here. So as the introduction, yes, I'm the country manager for Australia and New Zealand, as well as the sales manager for the APAC region at Nicolab. And today I really want to share a practical perspective on how AI-enabled imaging and cloud-based stroke workflows are really reshaping hyperacute stroke decision-making across one of the customers that we have in Australia, which is Queensland Health. And rather focusing purely on the AI algorithms, which I think everybody knows pretty well these days, I really want to talk about the workflow transformation because, as we know in stroke care, technology only matters if it helps clinicians make faster, more confident decisions for their patients. So joining me on the call today as well is Dr. Honey Singh, who is actually the country manager for India. And so if there are any questions after this webinar today, you can always reach out to her or myself with any of the questions that you may have. So a quick introduction, who is Nicolab? Well, we were founded in Amsterdam following the Mr. Clean trial which was one of the landmark thrombectomy studies that changed stroke care globally. And from the beginning, the focus was not simply detecting stroke, but it was solving the broader workflow problem around time-critical decision-making. And today, our product, Stroke Viewer, is deployed across Europe and the Asia-Pacific region, supporting more than 200,000 suspected stroke patients globally. And I will have quite a strong focus on Australia today, obviously being my backyard. But in Australia specifically, we now support the Queensland Health statewide stroke services, which is 44 hospitals. We have the Victorian Stroke telemedicine service with Dr. Chris Bladen, which supports up to 23 hospitals. And we also have some major private networks, including Sonic Healthcare. And the reason these large networks are adopting specifically cloud-based stroke platforms is because stroke care is fundamentally a coordination challenge, as we know, under severe time pressure. So I'm going to talk a bit now about the challenge in Queensland, and it's not very dissimilar to what you face, the same challenges or that I hear that you face in India. Queensland is one of the largest decentralised healthcare environments in the world, and patients may present hundreds or even thousands of kilometres away from a comprehensive stroke centre. If you know Australia's geography, then you'll know that everyone lives around the outside of Australia and there's not many people that live in the middle. But those people that do live in the middle still need to receive this amazing stroke care that they can get when they're in the metropolitan areas. So when a patient arrives at a regional or rural hospital, the clinicians really need immediate answers. Is this a large vessel occlusion? Is there salvageable tissue? Does this patient require a thrombectomy? And if so, where should they be transferred? Historically, those decisions were really difficult because there was multiple fragmented PACS environments. Specialists were all geographically dispersed and communication pathways were often really disconnected. So the real challenge wasn't just diagnosis. The real challenge was enabling statewide collaboration to where the clinician was located. So the solution is seamlessly connecting the hospitals through our product like Stroke Viewer. And one of the main enablers has been our cloud-native architecture. So the network now is able to connect hub hospitals, spoke hospitals, and the statewide Queensland Telestroke service, which is a new service that has been set up, including sites that are actually using private radiology groups to provide the radiology service in the public hospital. The images are sent directly from the CT scanner to our cloud environment for immediate AI analysis, removing any bottleneck that might exist in getting the images from the CT to the PACS, from the PACS to the AI tool. And at the same time, stroke neurologists, radiologists, and interventional neuroradiologists can access the same images simultaneously from anywhere that they are located in the state from their mobile device. So this eliminates many of the delays traditionally associated with manual image forwarding, bottlenecks around PACS access and limitations, and all of the disconnected communication workflows. So the main way that we have achieved that is through the power of the cloud. And much of what was on this slide I've already spoken about, but it's really by utilizing the power of the cloud, we're able to move images within the cloud architecture outside of the customer's network, which makes things faster in terms of being able to access and receive those images. And we've also given all of the stroke teams a single platform solution across the entire state. So this means they're not looking at CTP perfusion maps from CT vendors or other AI vendors that are out there. Everyone is looking at the same results on the same platform. Now, I apologize, this slide does look very busy, but it's to sort of provide you an overview of what the architecture that we've designed in Queensland Health is. And it looks technically complex, but conceptually it represents something really simple. All of the individual hospitals will still be able to work independently of each other. So if there is a clinician working at a thrombectomy centre or a hub site, they will just see their own images. But if they are also supporting spoke hospitals that are within their network of hub and spoke, they're also able to see the images from the spoke hospital. But we also have this really large telestroke bucket or partition within the cloud where every single hospital's stroke imaging will be sent to. And that gives a centralized environment for every single stroke study happening across the state to be located in one place. So if there is a neurologist or a clinician on call who needs to access those images, they don't need to log on to individual hospital solutions. They're able to simply log on to one location or one archive to view those images. This really means that they have faster access to the images and faster transfer decisions. And as we know, every minute counts in stroke care. The stroke workflow at each individual hospital really remains the same though. The patient will have a stroke, they're sent for CT or MR imaging. Those images are sent via a secure connection to the stroke viewer cloud. And then as soon as we've done our analysis, we send the results simultaneously to the PACS, to the neurologists or radiologists, and to the interventional team. And as I said, we also have this amazing ability to send to another stroke viewer instance, which is that centralized cloud to give all of the clinicians access to the same images. When we look at the outcomes, the impact becomes really compelling. Studies that we have studies that we've been involved in, and the links to those studies are down the bottom of the slide. We have demonstrated a 54-minute reduction in the time to expert notification, faster door to groin times, increased thrombectomy rates, and improved functional independence after stroke. One particularly really important point is that StrokeViewer has shown to help detect approximately 50% of occlusions that were initially missed in acute settings. But ultimately, the real goal is not the AI detection itself. The goal is reducing disability, reducing delays, and helping more patients return to independent living. So our Nicolab solution is delivered as a software as a service solution. And this is why one of the reasons why our cloud deployment has become increasingly important is really the scalability. So we provide the platform, we provide the algorithms, and we provide the workflow. And there's almost zero on-premise architecture required. So you can, once we set up the secure connection and we're able to receive those images into our cloud, everything is taken care of by Nicolab. And that's the true benefit of these SaaS models. Our platform as well is designed for fast alignment. So I've spoken a little bit about being able to access the images on a mobile device. And so we have a mobile app that's available once the solution is set up within the hospital to allow the physicians and clinicians to access the images. There is also a web URL access, and everything has an inbuilt DICOM viewer that allows the images that have been processed and the images that were originally acquired for the stroke study, they're all available in our cloud and are streamed directly to the device. So it means that We also send out notifications instantly on the findings. So if an LVO has been detected, we will send a notification to the teams. The doctor is able to open the study immediately. They're able to communicate with inside the platform using our chat feature, and they're also able to collaborate remotely inside the platform. So you can actually invite other clinicians who may not even be Stroke Viewer users to come in and have a look at a study with all of the patient information taken away from it to help you make a decision on the right workflow. And this becomes particularly valuable in after-hours stroke workflow. Our AI portfolio package includes our hemorrhage detection from a non-contrast CT, aspect scoring. For a CTA, we have LVO detection and localization, as well as our unique collateral scoring assessment. And we also have the automated perfusion analysis for both CT and MR. And each one of those algorithms contributes another layer of information that obviously helps make those decisions faster. The hemorrhage algorithm has two different outputs available. So we do have an option to have a binary red overlay, or you can have a probability scale to sort of show what the likelihood is of that being a hemorrhage. And we also provide the volume of the hemorrhage that has been detected. Aspect scoring, I'm not sure if this is widely used within India. It's certainly used in Australia, but this allows obviously the 10-point scale and automatic calculation and the visualization of the 10 anatomical regions. And we're able to provide that output. And all of these outputs that I'm showing here are actually also sent back to the PACS as DICOM object to be stored for permanent record. Our LVO detection and localization. So we don't just tell you that there is an LVO, we will actually pinpoint the area where that has been found with a blue bounding box that can be toggled on or off as needed. And our LVO performs a sensitivity of 91 and specificity of 86 for ICA M1 and M2 segments. So we have very high specificity even as we move up higher into the brain. Our collateral scoring, so this is something that's very unique to Nicolab and obviously can make a huge difference in the treatment decisions that are being made. The red side represents the affected side of the brain, and the green represents the unaffected side of the brain, and it is able to give you a percentage score calculation of that blood flow through the brain for the non-affected side to see, what is going to be the best way to treat this patient. And our automated perfusion, we obviously provide the CBF, CBV, Tmax, and mean transit time maps. We automatically segment the affected tissue, showing the core in red and the hyperperfusion in yellow. And we also now have a new multi-threshold output showing Tmax greater than 10, greater than 8, greater than 6, and greater than 4, just to help a bit more to show that perfusion of the blood flow through the brain. As we know, in perfusion imaging, motion artifact is a major issue. I used to be a radiographer once upon a time, and I don't think I ever scanned a stroke patient who laid perfectly still on the scanner for me. And so Stroke Viewer also has some really unique tools that differentiate us from our competitors around the way we deal with motion artifact. So we are able to really correct for that, not by removing time points like a lot of our competitors do, but by correcting for that motion. And we also provide some really important bolus graphs to show whether or not there was a good perfusion or contrast bolus given to that patient, and that you're making decisions based on that. So rather than just simply rejecting poor imaging or poor quality data sets, the platform really attempts to correct motion and preserve the usable imaging information to improve those decisions. This is a quick example of the DICOM report output as well that we're able to produce. So this is sent to the PACS as a DICOM object as well. And so that's a nice summary of all of the algorithms, all of the findings, the calculated volumes, etc., that can be, stored away as a permanent report. So I just want to move a little bit now, moving back to Queensland and talking a little bit more about the outcomes and analytics. So one of the unique things that we do under our subscription-based model is that every single customer that has a subscription with Nicolab, we provide quarterly insights and analytics meetings with our customers. We call them customer success meetings. And this is where our team of experts are constantly looking at the data that's being produced by the stroke viewer instance at the hospital or across the multiple hospitals. And we're able to present that information back to our customers to help you sort of really pinpoint any areas where stroke workflow can be improved. And this is an example from earlier this year. This is from the 1st of March to the 31st of May. And so far, we have analysed over 3,347 scans within Queensland Health, with a suspected ischemic stroke found in 966 of those, around 28.8% of total cases, which seems to be pretty standard across the board, and with hemorrhagic stroke being around 5.5% of the total cases. So this is just really interesting information that we present back to the customers each quarter. It also includes more detailed insights, and we're constantly building on these, and they're sort of adjusted based on what the customer needs, but we're able to show the amount of user activity, so the number of patients that are being viewed in the mobile app versus being viewed in the PACS. We're also able to have a look at the workflow timing. So this is the time it takes from the images this is in minutes, by the way, the time it takes from the images to be sent from the CT scanner through the customer network into our cloud and be analysed and be viewed back in the Stroke Viewer app. So on average, that's sitting at around 10 minutes, which is pretty amazing. And then we're also able to break that down to have a look at non-contrast CT, CTA, and CTP. So we can really see where the time is being spent. And typically the CTA pipeline does take a little bit longer to run than some of the other ones that we have. But it's really interesting information to be able to share back with our customers. So I also wanted to talk a little bit more about what's coming and the impact that this will also have on some of our customers, including Queensland Health. So this was, I think, what was presented, or some of this was presented at ESOC. And so what we are working on is a digital clot biopsy algorithm output. And this is one of the areas I'm personally most excited about. It's certainly one of the things that attracted me to come and work at Nicolab. Because as we know, thrombectomy planning today still involves a real degree of uncertainty around clot composition and behaviour. And so the idea behind this algorithm is to be able to extract information from the CTA that gives us the clot structure, the permeability, the composition, and the treatment responsiveness. And so the idea will be that through these images that you can see here, you'll be able to see whether or not it's a fibrin-rich or very calcified sort of clot. And obviously that can make a difference in the type of device that would be used by the INR to go in and try and extract that clot out. And so very valuable information. We can tell you the length, the volume, the diameter, and all of this information. And you can see this rotating image down in the bottom right here. This is where we're moving to under our collaboration with Philips, and it's being able to then overlay that clot output image onto a live image within the IGT lab or on the Azurian platform specifically to help when navigating up with the wires and catheters to extract that clot. So some of the sites down the bottom here that have helped us with this and the way it's been built, and we're still working on it at the moment. It's not quite ready for commercial release just yet. But is we actually get the clot that's been extracted and correlate against that histology to build our algorithm. And the results so far have been extremely promising. So here's just some other examples of some of the images that we've been able to produce. And I'll just play this again. So this is just another view of how you can see there the sort of grey area, which is that clot piece. And, we'd be able to provide the information on what the composition of that clot is, and that would be overlaid onto the 3D model that would be acquired within the lab. All right, there we go. So just to close out here and talk a little bit more about the platform vision. So obviously having that type of algorithm, how Rice spoke about it at the ANZ SNR conference earlier this year, is having that level of detail around that clot algorithm will make a huge difference to him in making a decision about whether or not that patient would be potentially put in an aeroplane and flown for, thousands of kilometers away to Gold Coast to his facility. If that was a clot that was, almost impermeable, or he knew that that was going to be really tricky to get out, they may make a different treatment decision and avoid the cost of transferring that patient to the facility. And so he thinks that by having that information and not needing a perfusion scan necessarily to get that, just from being able to do a CTA, will really be a bit of a game changer for Queensland Health. And the last slide I'm showing here is just to talk a little bit more about our platform vision. And hopefully you've been able to see today that our product is not just about the algorithms. Our product is about the workflow and being able to connect all of those hospitals. And so we have today our stroke algorithms, and we hope to add on this clot algorithm in the very near future. But we will also become a platform for other algorithms. So we have been approached by a number of companies globally that are producing medical imaging or CT algorithms. And they are very keen to get their algorithms embedded into our product because they can see the benefit of the Nicolab platform, which we call, the base platform is called Nicolab Assist, which is the platform and the workflow. And then over time, we will start to add other algorithms in there. The first one we're looking at is a pulmonary embolism algorithm, which would work in exactly the same way in terms of workflow, but obviously the notification that we would send out would go to a slightly different team of people than the stroke team. So what I really want to say is, I guess, that the future of stroke AI is not simply about the algorithms, it's about connecting clinical ecosystems. And the real opportunity is integrating imaging, AI, and communication, workflow and decision support into a seamless emergency care platform. And that's what we have done in Queensland Health, connecting 44 hospitals together with a telestroke service. And we can see how that cloud native solution has really helped overcome the geographic barriers and support more equitable access to stroke expertise. And it has also added a number of sites or number of my favourite holiday destinations in Queensland back onto my list of places to go. So I know if I do have a stroke there, I'll be very safe in getting the right treatment.
Right. Thank you, Kylie. And I think that was, thank you for this wonderful, detailed and comprehensive account of the Nicolab Stroke Viewer. I think one of the biggest needs that we have to run a stroke system is to not only have the physicians in place, but to have them working as a team. I think the team viewer that you've shown has huge potential in any kind of a system that it gets, starts working in or gets implemented. And let's go on further with our discussions today. So we have, would request you to also be part of the discussion, Kylie, and we have,
Sure.
and I've introduced the panelists. So let me just start first with the first question that I had about stroke pathways and workflows. So Monica, this is for you. Now you've had experience in 3 countries. You've looked at the Indian system. Do you know how it works? There's a huge kind of a disconnect. We have district hospitals which now have at least a good number of them have CT scanners. And the telestroke networks are still, at best, I would say, still very fractured. We still don't have very organized telestroke networks where hub and spoke communications are there. And you've seen systems in, where you've trained in Canada and Singapore, which is, I would say, one of the havens of healthcare in the world. So how do you see such a system, improving pathways? And first of all, you think implementation in India, and specifically if we're talking of country like India with a huge stroke burden, such a system would place, of course, everyone at an advantage. But what kind of challenges do you see?
A lot of challenges, actually. Before I answer, I actually had a lot of questions for Kylie.
Yeah,
Is it
sure. Go
okay,
ahead.
Kylie, if I ask you some questions?
Of course, yes, go ahead.
Okay, I have many questions, but they'll fall under 4 categories. So my first question is, I know you're partnering with Philips in Singapore and you have Philips partnerships in other countries. So I'm assuming your algorithm is workable across all scanners, correct?
Correct,
All kinds
yes.
of scanners. Okay.
Yes, absolutely.
My second question, because I have lots of questions, I'll move fast. My second question, your training database comes predominantly from Europe. Am I wrong or right?
The original algorithms were built off the Mr. Clean data set, but since then, obviously, we've had access to a lot of other data sets across the globe. So most of the contracts that we had within the US were all to be able to have access to their data as well. So the data set has certainly grown over time. So it's no longer just a European focused data set.
So my question would be, because Asians have a lot of ICAD, right? And that does create a little bit of a problem when you're analyzing images. So how much of your training data set is from Asians? And do you think that's a problem when it comes to your errors and your positive predictive sensitivities?
Yeah, it's a great question.
All those data.
I don't know specifically the percentage of data sets or how much we have access to. One of the biggest challenges we face as an AI company is access to data sets. It is a challenge globally. And, if you want to buy them, they're very, very expensive. And we try not to do that. But most customer sites are very hesitant to be able to share patient health information and data for the purpose of AI algorithm building. I think as we started to do more installations into the Asia Pacific region, we're going to start to see whether or not there is an inherent issue with the way the data has been trained. And if that is the case, we're always looking for sites that would be willing to share their data to help us improve over time. But obviously that's not something that happens, quickly, because we can't constantly be training our algorithms. We don't get past regulatory for that purpose. Everything has to be done in a very structured way. So
it actually takes me to my next question. So privacy is a big issue in many countries. In India, that is not much of a problem, unfortunately. So my question to you is, whose data is it? When we're uploading images into your cloud, do you own the data? Do you sign some kind of agreements with people? So, my next question. Your subscription, how much does it cost? Do you have a tiered system of costing? Is it the same cost in Australia, Singapore, and India, or is it going to be different? And I'll interrupt here, because cost is not just installation and subscription. It's basic stuff, it's training, it's upgrades. So when you're adding in suites, obviously you're going to charge for them. So when we come for cost efficacy analysis, these are things which are normally excluded out of analysis. People just look at patient quality years, etc., which is really a very rough estimate. So how much do you cost? And what is your system for all the basic stuff? Do you provide training? Are there online platforms where free training is provided? What about the upgrades? Are you planning to charge for them?
Yeah, great question. So typically our pricing varies based on each market. So there's, market pricing that's set by our competitors and things. And if we want to succeed in a market, then we need to stay price competitive. Just recently, we've sort of undertaking a process of restructuring how we sell our product to sort of break it down to be a little bit more modular. And that is to allow us to be more price competitive in the market. And so that way, if there are things that people don't want, we'll be able to take them out to stay a bit more competitive. I don't have a cost that I can give you today because it obviously varies in every single market, and it does vary on the scope of how many hospitals. So, we have a single hospital price. If you add in spokes, if you add in 10 spokes, it's going to get a bit cheaper based on the volume that we have. So it's hard to give you a fundamental price, but we are a subscription-based service, so a SaaS model. And so we typically try and sign customers up to a 3-year agreement. And then for the course of that 3-year agreement, they're charged annually for our service or for our subscription. And our team in our headquarters control the software. So as updates are included. So they might be things like, we've just recently done some improvements to our CTP. Every single customer globally gets that. We don't charge for it. We just push it out. We recognize that there were some improvements that could be made in the way that we present our data, and we push that out. If there's updates to the mobile app, or if there is some new funky features, we might add a new thing inside the mobile app. That's all pushed out and included in your subscription model. If we produce a new algorithm, for example, if you had Stroke Viewer today and that clot algorithm that I was talking about became available, we're probably not going to give that to you for free. That would probably be something that you would have to purchase as an additional add-on. But that would just add to your subscription price. And obviously any of those third-party ones that would become available would be charged based on the third-party person that we were working with. We have a one-off implementation fee, so we just charge that at the beginning, and it is very, very competitive. It is literally us just clawing back the cost of us setting up the cloud infrastructure as an initial cost, and the cost for our team to do that. And it's a very small amount in comparison to what we see from our competitors. And it's just charged once at the beginning, and then once it's set up, there's never any additional charges for the setup.
The charges, that's understandable. It's going to be a subscription based, like we have your competitors who've been doing it. But what if I don't think so. It's still being initiated in our country as of now. I'm not sure of that. But since there are instances where companies have come in, they look at it as a opportunity to go into trying out, setting it up, and they may not charge for the initial couple of setups so that they can even have the experience of setting up such networks, as well as get an agreement that you would be utilizing the data. Has that ever been thought of or initiated? And I think we'll go next.
We have a number of different sort of commercial contracts with customers. So we have what we call reference site agreements, where the customer will get it at a discounted price. In return for that, we get some access to data or some marketing support, or we ask people to speak on our behalf at conferences and things like that. That's something we certainly do. But what I wanted to add as well onto the subscription cost is we are also exploring like a price per patient type model. I don't like calling it per patient because it's really per algorithm or per analysis that is done. And we're looking at a number of those models. So Honey, your local country manager in India, and I are still working through how that will look. We've had our regulatory clearances in India for over 18 months now, and we have our first 3 contracts in India, obviously with Dr. Biplab at Batra, at Tata Memorial Hospital, and also with Dr. Pandian at CMC Ludhiana. So we're still in the process of installing all of those solutions to get them up and running. But we're on the way, and we're just trying to still sort of feel the market and work out what's the best way for us to provide the right stroke service to the market.
Great. So we have comments from Ayush. Go ahead, please.
Thank you. Thank you for your presentation. I'd just like to add something on what Dheeraj sir already spoke about. So most of these softwares are cost prohibitive, especially if you're working in the government sector, like Dr. Dheeraj, Dr. Chirag and I are. And at ESOC this year and World Stroke last year, I did reach out to a lot of other people who were there in the exhibition area. And the approximate cost, if I remember correctly, which was told to me was around 3,000 to 4,000 euros per year per machine. which is something that is usually not something that at government hospitals most centers would agree to, because traditionally we have 2 MRI machines or 3 MRI machines, so the cost goes up threefold. So is there a way, one, as sir suggested, if like we have a lot of patients coming in, if we could share patient information and patient data, which would help you make the Indian subcontinent centric database, as Dr. Monica was speaking about, we could get it at a reduced price. Second, a lot of research projects do go on here. So if we could get it on a research model, which should be a little subsidized for us, because we have a lot of patient load. We just don't have the funds to be able to get this software, because of which we use like the machine-based CT perfusion model, which are not as accurate as your softwares and things of that sort. And with Telestroke coming in, we're mainly using WhatsApp to transfer images from the spoke site to the hub site, where we just, browse through, and it's still doable. But if we had a software like you have, and, it could help move things much faster in a much better way, like you showed for Queensland. So just
Yeah. No,
So more
absolutely.
like partnerships, like?
Yeah, absolutely. And I mean, that's how Nicolab has been so successful now, up until now, has been through partnerships, and it's really finding the right commercial model that fits with the budget that's available, and what's feasible. Our biggest cost as Nicolab is cloud infrastructure costs. So obviously we're bearing the cost of the cloud storage, the cloud, the GPUs that are required to run the pipeline algorithms and those types of things. So we need to cover our costs for that side of things. But what I do know, and what I'm learning as I've worked at Nicolab, is the more cloud we have in a particular country, because everything stays within the borders of the country it's installed, the cheaper the cloud costs become, right? So it's our job as Nicolab to go, negotiate with Google and Amazon and Azure and everybody else to get the best cloud infrastructure costs. And the more we sell and the more customers we have live, the cheaper those cloud costs become.
Something just kind of related to this. Sorry to cut you there, but the servers, the cloud servers, do you base them country-wise? Because India has this condition that it has to be within the confines of the country.
Haven't found a country yet, apart from New Zealand, who doesn't have any cloud infrastructure, that won't allow images to leave their borders. So we always stay within the borders of that country.
Great. So let me just quickly go to the next question with our next panelist. I'll have a query here for Chirag. So you've looked at it. We've all India is known to produce low-cost solutions, and any kind of an innovation, we try to look for that. And for obvious reasons, we try to we need to implement it in a huge population. You're probably aware of that. So Chirag, do you think such a solution? Of course, it's going to be very useful, but how about the implementation? You think we could implement it in, say, tertiary care hospitals like ours, and then connect them to other hospitals? What's your take on this? As Ayush just pointed out, cost as one of the things. Do you see any other challenges in implementation of it? It's a very useful system, and one of the things which I can think of is, as a low cost alternative, is to look at only some part of the information that we are seeking, which may be very relevant to our population. What is your take on such a platform?
Yeah, I think a very relevant question. The problem I think we face, as you yourself has seen in the last so many years, is integration and association of the various spoke and hub units. So even if we acquire the software, the first question will be, who will pay for it? Will we as hub pay for it, or will the government share? Because most of these systems in the district hospitals are really run by the government. And we really face huge problems in getting them on a single platform, convincing them that this would be the right approach. And more than that, even I believe if we have everyone on board, it's really a problem if, let's say, a patient actually is a candidate for thrombectomy, and the patient is, according to the software, needs to be relocated to the hub center, let's say our center. The next problem is, how would that happen? So obviously that's beyond the confines of what we are discussing, but these are the practical problems that we've been facing for the last so many years, I would say. So that's the problem. I have another question apart from the ones which Dr. Monica has already shared. Most of them have been covered, but the one question that I have for you is, Kylie, is how is it different from the other software platform? Because we already have one platform, we have the Rapid AI with us. And how would you say that you outscore or outperform the other already existing softwares which are already there with us? And just a comment here. We have seen problems with Rapid AI. We've seen false positives. We've seen hemorrhages being shown as infarcts. And my question is have you, as a company, really compared the already existing softwares in the market across the globe with your software, and how does your software perform in terms of accuracy in both perfusion imaging, detection of hemorrhages, aspect scoring, and is there a way that we can say that you are better in terms of these aspects than the others already there?
That's a great question, and I don't really like the term of better. I think all of the solutions that are on the market are providing a really important tool for stroke. In order for us to get regulatory clearance that we had to get in the US with the FDA and in Europe with the CE MDR certifications, we actually need to be correlated against a competitor. And so Rapid was the competitor. And so that has already happened. And all of our clinical claims and everything are made against the Rapid product. Now, since then, we've obviously made a lot of improvements to our product. And we've just recently got some CTP changes that are actually getting rolled out tomorrow. And I'm ready for head-to-head comparison with Rapid now, because we did sometimes get some challenging edge cases, I would say. And there's certainly some documents and some publications that I can share with you where we have been compared. I don't think any AI solution is ever going to get to 100%. We're here to support the clinical workflow, and I think a false positive is better than a false negative always. And yes, we still get cases on that. In my presentation that I joined last week with Queensland Health, that quarterly review meeting, it was funny because we presented that slide on 995 cases that had been done in the last 3 months, and they kept bringing up 3 cases that there was some challenges. 3 cases out of 995. Everyone's forgotten the 992 that we performed perfectly well and we had great results and the images all did exactly what they were supposed to do. People tend to get fixated on these cases, and when we do a deep dive on those, it's often a poor imaging bolus, or the patient moved so much we couldn't analyze, or there was huge artifact on that patient because of a brain coil or something like that. So it's hard to sort of compare, like, unless one competitor and the other competitor are using exactly the same data set and doing a real sort of head-to-head comparison like that, I don't think we're ever going to know. But to answer your original question of why I think Nicolab is I'm not going to use the word, why we are better in a way, is certainly our workflow. So being cloud native, so we don't have an on-premise offering. We don't do that. We are only in the cloud, and we use the cloud to our advantage, right? We don't care about your network and how bad the images, trying to move from a hub hospital to a spoke hospital. We do that in the cloud. That just happens in a minute. We just move the images from one to the other. You open up the mobile app, you got access, and we're done. We're not moving images through PACS systems and networks that are poor and bad latency and all of these things. And so having that available to us and being in the cloud is a huge advantage. I would also say that our collateral output that we provide is also a bit of a game changer. And knowing what's coming with our clock characteristics algorithm will once again really position us in a great place in the future against the competitors.
Great. So just before I go to Monica, just one quick question which I just came to my mind as you were talking of this of the workflows and the way you share it. Now, an interesting aspect which I did happen to get an opportunity to see in this stroke viewer is the ability to transmit the images as well as the entire the view of the patient into another phone through a link, even a phone which doesn't have software or the installed application. So in that is that already how does that improve your system? One. Number two, you charge extra for that as just part of the
No, it's all included. Yeah.
okay. And
Yeah.
what about does it make any compromises in the privacy or the ability to lose data to
Yeah,
another
great.
link? Because anybody can send a link, right?
Great question. And so what we're talking about here is our collaboration tool. So inside the DICOM viewer, inside our mobile app, there's a little button that you click and it says collaborate. And so you just type in the email address of who you want to send this to. They don't need to be a stroke viewer user. And they will receive a link via a text message, and they quickly log on with that, and they open it up in a web browser. So it's not within the mobile app, it's just within a web browser, and they get access to the images, and it's like a mirror. So it's real-time screen sharing. So as I would scroll on my phone, the other person would see the same thing. And so I zoom, roam, do whatever I'm doing to those images. The other person is seeing exactly the same thing.
Exactly.
But they have no patient identification on there. So we've stripped out the patient name, date of birth, everything. It's all completely blank for the person receiving on the other end. Now, I saw this in use when I was at the VST. There was a neurologist, I was sitting with him, he was looking at something, he's like, oh, sorry, this is just really confusing. I'm going to collaborate with a doctor who I know is I think he was in Alberta in Canada or something. He sent a link to him because he goes, he's an expert on these lacuna waterfall, I didn't even know what he was talking about, type of stroke. And he sent the link. And so we had a doctor in Canada and this guy in Melbourne sitting there sharing that same patient and making a treatment decision right there together on what was going to be the best course of treatment for that patient. That doctor in Canada couldn't see the patient information, can't do anything. And the second you close the collaboration session, that person's kicked off. There's no data stored on the phone. So it's very secure and safe.
It goes without a trace. I think that's an excellent collaborative tool. So next question, Monica, and then Pushkraj.
No, I just wanted to know whether your system has ever had any failures or shutdowns or breakdowns.
No, I mean, we had one incident in Sydney where we ran out of GPUs, or Google ran out of GPUs. I think too many people were using ChatGPT at the time, and we ran out of GPUs. And so we had a couple of patients that failed to analyze and were a bit confused, but we were able to resend them and then they were completely done. But we're, based on cloud infrastructure. So it's a 99.9% uptime guarantee. Obviously, all those major cloud manufacturer or cloud infrastructure suppliers are providing that service for us. So yeah.
Thanks.
Pushkraj.
Hi, thank you for the wonderful talk, Kyle. Just one question. Although India has one of the largest 5G networks amongst the world, but what problem that I have seen in tier 2 cities or tier 3 cities is that the hospitals, usually inside the hospitals, there is very low bandwidth. So have you tested out your entire application in such low bandwidth settings? Because your time is critical. So does the hub and spoke model also work in low bandwidth areas?
Yes, it does. And so what we have is part of our secure connection from the scanner to the cloud. We have what we call a relay server. And I don't like the word server because it makes you think of hardware, but it's not hardware. And this device also allows us to compress images a little bit. So in those really low bandwidth, and trust me, Queensland has the worst bandwidth in some of those remote locations that I've ever seen. And yes, there will be a slightly longer transmission time, but it was nothing. We were able to sort of improve that by using the relay server. There are also third-party solutions out on the market that can sit between the customer infrastructure and our infrastructure if it becomes a real problem. But I don't foresee we would see anything worse in India than what I've seen in Australia, even though we sound like we're really advanced over here. Our internet connections are dreadful.
Great.
Minimum requirement for the bandwidth? Sorry.
I don't know off the top of my head. I would have to go and look it up in the technical document. Sorry.
Okay, sure. No problem. Thank you.
Biplab, you had a question or a comment?
Hi. So, nice practical sessions going on. Yeah. Just to add, because as you explained, the difference which you have, the platform, other platform which is there are not lots of platform, only one or two platforms are there, but which slightly different. As Dr. Purana has already said, is like you have a link, that can be shared with the other persons. And for interventionists like me, the projections which is there inside the cath lab itself, which we can see system, that which vessels is, that is, yeah. Second thing, I just wondering, you say that your data, you are working on that. The vessel occlusions, LVO, the length of the clot burden, so that is fine. But compositions is also something which you will be able to give some ideas down the line. Composition of the clot. Okay, that might be helpful also, because patients who are, especially Asian patients who are ICAD, already Dr. Monica has said about that one. One of the for the cost is always there, but as subscriptions or more and more hospitals, and you have more subscriptions coming, so naturally it's going down. Hopefully it should happen. So one of the queries, like, hub and spoke model. In the spoke model, in a center, supposed to be, they want to get, add to the hub this connections, or what is the minimum requirement of the city configuration? How many slides?
So we've got like a table that has the minimum requirements, but it's not like we don't need thin data. We actually don't want thin data. Thin data just takes longer to process. So I think it's like 3 millimeters for a CTA. But what we see typically in Australia is a lot of the CT scanners that are out in those regional remote centers don't do CTP, because you've got to buy the license, put it on the scanner, all of the rest of it. So in those instances, they'll just send us the non-contrast CT or the CTA, and we'll analyze that and send the results out. And if they don't have perfusion, that's okay. We just don't analyze it. So in the spoke centers, we can actually do a cheaper license because they're not using the perfusion algorithm as well. Or if they can't do CTA, like some of the sites, you can't inject contrast without a doctor present, these types of things. If they're only just doing the non-contrast, at least we can give them a hemorrhage detection, yes, no sort of answer, as well as the aspect score, to at least make an initial decision and have a look at it. And then the patient can be transferred for further imaging if required.
Right. So I think we're reaching close to the time of the webinar, but I have one last question to Ayush. So Ayush, you've been working as you've been one of the future stroke leaders of the WSO. And I believe the area that you have an interest is the hub and spoke telestroke networks. So currently, if you must have looked at networks in India, some of the networks across the world, where do you see such a system? Of course, there's no other question. It's of course useful. How many networks, or I can't say how many, but to what percentage of networks have already implemented something like this, similar to this, across the world? Or if you have any experience in that, can you inform us on that? And has any other network in our country which is close to getting such kind of a collaboration? And how would this be implemented? How can this be implemented?
Thank you, sir. That is a very interesting topic, actually. So we, as a part of our Future Leaders project, we did a project on telestroke, and we reached out to all the network operators all around the world. And we had around a 30 to 35% response rate. And to no surprise, most of the networks that we identified through the survey were from the high-income countries. But one interesting finding was that if we looked at surveys that had become operational in the past 2 to 4 years, most of these were happening in the lower middle income countries. Amongst the high income countries, most of these were in Germany and the United States, as is expected. And most of them have some software system that they're using, whether it is Nicolab or the others, without taking names. But the ones that are now coming up in regions like Brazil, in India, and the others, everybody was using some sort of an indigenous model. We had done a project under Professor Padma called Smart India, where we developed the app for sending images across. They have a similar software that they've made in Brazil under Professor Sheila Martins, which is being used for telestroke there. All other research telestroke networks that were being used in the Indian subcontinent were mostly based on the smartphone applications like WhatsApp, where people had gotten hub and spoke centers. One was there in West Bengal, one was there in the southern part of the country. So there is a lot of, it's very promising for software like this to come in. But as I said earlier, I think cost is the only issue. And data sharing, I think there is a workaround that is possible, because with more and more projects that are coming in, I think if we could incorporate this in a research project via one of the funding agencies and establish it the major thing would be establishing, as Kylie had told us, that one-time fees and the cloud being set up. And once it takes off, I think we'll find more and more hospitals trying to take this up, maybe through the rescue registry or things like that. So I see a lot of promise. I just hope that we can tap into it and provide this to our patients.
Thanks, Ayush. And I think the discussion can go on and on. But like you said, rightly, we these networks, these smartphone applications, we even have one of the applications. Sorry for that. So most of these applications, we still do not have the indigenous ones, especially. They are nice, low-cost ones. They still have not integrated technology within them. We have simple hub and spoke ones, which we are utilizing. I think it's a great opportunity for us to look into such technologies and how we can integrate into a low-cost solutions. With this, I think we're reaching close to the end, and I've been asked by the organizers to wind it up. So before we wind it up, thanks, Kylie, for taking all these questions. You were bombarded with a lot of them, but
It's fine. Any
thanks for
that
that.
weren't able to be asked, please shoot them through via email or however you'd like
Sure,
to
you're
get in
going to
contact
have a
with.
lot of queries coming in
Yeah,
the
that's
coming
good.
days.
That's
So
exactly what we like.
to give the final conclusion, I hand it over to Biplab.
Yeah, thanks, sir. So thank you, Kylie, and all our panelists. Wonderful discussion, actually. And this your platform is very exciting also. As Ayush is also saying the same thing, like, you have more associations or some sort of research, then probably you'll have a more platform. So, I mean, more hospitals coming, and then there will be lots of people or hospitals to be benefited. Okay, so I think thank you very much for taking out your time on Sunday. Thank you very much, I think. Okay, so see you again. Good day.
Thank you, everyone.
Thanks so much.
Bye.